Hello everyone, today we will be solving this nice integral which appeared in Putnam Mathematics Competition of 2005. I will leave the set of problems for that competition in the description. We will be using Feynman's trick to achieve that, so go ahead and give a like to the video and subscribe to the channel, and let's start. First of all, if we draw the function inside the integral, our integral will represent the shaded area between our curve and the x-axis, when x is between 0 and 1. As we have seen when using Feynman's trick, we start by considering a function that is defined by an integral that depends on a parameter. That parameter in this case is y, and if we plug in y equals 0, the function f will be equaling 0, so f of 0 is 0. We will use that fact later. Let's write our function here, and let's differentiate the two sides with respect to y. Now, for the right-hand side, we will use the Leibniz rule, which is the essence of Feynman's trick, which says essentially that we can interchange the derivative and the integral signs under some conditions. Applying that to our function, we get the following. This is an easier integral because we can clearly use partial fractions, then integrate, and we get the following. At this point, we will integrate both sides between 0 and y, and since we have seen in the beginning that f0 is equal to 0, we get the following expression. If we plug y equals 1 into our last result, our integral appears on both sides, and when we solve for it, we get the value of pi over 8 times the logarithm of 2. I hope you enjoyed it as much as I did. Subscribe to the channel, and to the next video.